We are talking about reflections and translations, and we want to be able to draw translations in the coordinate plane. A translation takes a figure and slides it to a new location along a vector. That's what it's called. It is not rotated, reflected, or resized. So a translation takes a figure and slides it to. So here we have the pre-image A. It's slid to a new location where A prime is, and that is the image. A figure can be translated left or right, and that you can see that's has to do with the X value, and can be translated up and down, and that has to do with the Y value. So the X coordinate is subtracted. So for this one, we're going to use subtraction by number of units moved to the left. So whatever you move to the left, you subtract and move it to the left. The X coordinate is added by however far you want to move it to the right. So this one is going to be addition. The Y coordinate is subtracted by the number of units moved down, and the Y coordinate is added by the number of units moved down or moved up. So some other pieces of information. Each segment joining a point and its image has the same length as the vector. So in this case, the vector k and that's what that symbol means there. This is called vector k, where it's a lowercase letter and it has like half array written above it. The segment is parallel to the vector. So the distance moved is parallel to the direction that the vector goes. And we'll take a look at that in a little bit. So then we come down here and we can see that vector can be written as the vector parentheses, which is that angle mark. It's not an angle mark, it's the vector parenthesis. It is above the comma and the period on your keyboard. AB where A is the horizontal shift in the X direction. So whatever that value is, you slide left and right. And B is the vertical Y direction. So when we go ahead and do that example, this is a capital T for translation, AB, and we're going to apply it to X and Y. So basically it says add A to X coordinates and add B to the Y coordinates. The other way that you could have wrote this as, AB. So A is going to move it left and right, and B is going to move it up and down. So to translate a point along vector AB, add A to the X coordinate and B to the Y coordinate, similar to how we have it written right there. So in this example, it says translate triangle ABC to the left 8 units and up 7 units. So we could write it where we could say capital T, and we want to move to the left 8 units. So we're going to put our sub value of -8, and up 7, that's going to be positive 7, and then we're going to apply that to all the x and y coordinates. Another way that we could write it is we could write it as our vector notation, and we could just write it as negative 8, comma 7, just like that. So all we have to do is we have to take our pre-image where we have our values of A, B, and C, and we just have to apply this translation or the shift. So negative 8, positive 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So that's going to be A prime. So then we're going to go over 8. 1, 2, 3, 4, 5, 6, 7, 8. And then up 7. 1, 2, 3, 4, 5, 6. Which puts us right here. That's going to be B prime. And then C prime is 1, 2, 3, 4, 5, 6, 7, 8, and then up 7. And it should be on the same line as B because they're on the same line already. 1, 2, 3, 4, 5, 6, 7, 8, and then up 7. Put us right here, and that's going to be C prime. And then we can sketch our new image. There was a part that said the segment is parallel to the vector, or how it moves. So the vector moved like this. But all of these movements are going to be parallel. So all these vectors are parallel to each other to move the pre-image of triangle ABC to the image of A prime, B prime, C prime.